Lesson 7-3, negative exponents. So the zero exponent property, any non-zero number raised to the zero power is equal to 1. For any non-zero number a, anything to the zero power is 1. We are going to get to negative exponents, and in our answers we cannot have negative exponents. But first, the first part is dealing with zero exponents. So here, simplifying the zero exponents. Here, if we're going to raise everything to the zero power, and when you raise a power to a power, you multiply them. Everything would be 0. Everything raised to the 0 power would give us an answer of 1. So for this one, our answer would be 1. Letter B, this would be a to the 4th. Remember, when you raise a power to a power, or when you divide like bases, you subtract the exponents. And then b to the 0 is just 1. So I could put this times 1, which will give us an answer of a squared. Next one, anything raised to the 0 power, so everything's raised to the 0 power, that is equal to 1. Here, the w to the 0 power is 1. 6 divided by 2 is 3. And I have u 2 minus 1, and then v 6 minus 3, which will give us an answer of 3u v cubed. Next, select the simplified form of this expression. 56 divided by 8 is 7. G to the 0 power is 1, so I'm just left with g squared on top. H to the 0 power is just 1, so I'm left with just h on top. J to the 0 power is just j, or is 1, so I'm just left with j to the 11th on top. So I look at my solutions, first places, I have 7g squared. I know that can't be b, can't be c, h, and then j to the 11th. The only one that would give us that answer is letter A. Now moving to the negative exponents. Any non-zero real number can be raised to a negative power. That power is called a negative exponent. And when you work with negative exponents, you need to get rid of the negative part by writing the reciprocal of the base, and now your exponent is now positive. So the reciprocal of the base removes any negative exponents. So if I have 3 to the negative 5th power, the reciprocal of 3 is 1 over 3, and then I raise that to the 5th power, which would give us 1 over 243. Likewise, if I have a negative exponent in the denominator, the reciprocal of 1 over m is m, and now it's positive squared. An expression is considered simplified when you have these 4 statements. So it contains only positive exponents. You want to verify that all the exponents in your answer are positive. The base appears exactly once. You don't want to have the base appear more than once in there because you could still simplify it. There are no powers of a power. So you can only have one exponent on each variable. And all fractions are in simplest form. So you need to simplify any fractions that you have in the problem. So an example, b cubed, b to the negative 4th divided by c squared, negative 2nd. So a cubed is fine. B to the negative 4th, the reciprocal of b is 1 over b. Now it's positive. And then the reciprocal of 1 over c to the negative 2nd power is c squared. So our answer would be a cubed c squared divided by b to the 4th. Next one. If I were to write this, this is c to the 4th. That's fine because the negative is not on the exponent. F to the negative 2nd, I need to do the reciprocal of that one. So the reciprocal of f is actually 1 over f. And then that will be positive squared. The d to the negative 7th, that has to go to the top. So that would be d to the positive 7th. E cubed is fine on the bottom. So my answer would be negative c to the 4th, e to the 7th, divided by f squared, e cubed. Next, simplify this one. We have numbers in there, 42/14. We can simplify 42/14 by, that would give us 3. So we'd have 3 in the numerator. And then r squared, so we have r to the -2 minus 2. We got t to the -6, and we got u cubed minus a -3. So if I simplify this, this now has r to the -4, t to the -6, and then u to the 6th. I can't have negative exponents, so these two need to go down. So I would have 3u to the 6th all over r to the 4th, t to the +6. And the one solution that gives us that would be letter B. Another example, we have 3 and -36 we need to simplify. This would be g to the -3rd minus 3, h squared minus 1, and then j to the -4th. And then j to the -4th is on the bottom. So I'm going to put j to the -4th here. When I simplify it, 3 divided by -36, we would have 12 on the bottom. -3 minus 3 is -6, so a g to the 6th has to be on the bottom to make it positive. I would have h on the top, and then j to the 4th as a positive exponent there. So our answer is HA4 divided by 12 g to the 6th. Next, simplify this one. Remember, anything to the 0 power is just 1, so I have -8 divided by 2. And then I have an r here. T to the -3rd, that needs to go on the bottom, positive, and then I have t squared there. V to the -10th, put that on the top, or the bottom, and then I have v to the -5th already there on the bottom. Now if I simplify this, that gives me a -4 on top. I have r t to the 5th, v to the 5th. All of that would be in the denominator. A couple more examples from example 3. Select the simplified form of this one. So 35 divided by 14, I can divide the numerator and denominator by 7. If I divide the numerator and denominator by 7, that gives me 5 and 2. And then h to the 0 power is just 1. So we should still have an h squared on the bottom. That leaves us with b cannot be it because we have h on the h on the top and bottom, so that's not simplified. Let's see, we got j to the -5th. That has to be on the bottom as a positive, so j to the +5th on the bottom. So the one that we have h squared on the bottom, this one can't work. H squared in the bottom is here. J to the 5th on the bottom is here. This one does not have h squared in it, so it can't be a. K to the -2nd needs to be on the bottom as k squared, and then m to the 5th. Our correct answer would be letter C. Example 4, applying the properties of exponents. Order of magnitude is used to compare measures and perform rough calculations. The order of magnitude of a quantity is the number rounded to nearest power of 10. For example, the power of 10 closest to 105 million is 10 to the 8th, or 100 million. So the order of magnitude of 105 million is 10 to the 8th power. So let's look at a word problem finding order of magnitude. The maximum speed of a peregrine falcon is about 90 meters per second. The maximum speed of a garden snail is about 0.01 meters per second. How many orders of magnitude as fast as a peregrine falcon is a garden snail? So another way of stating the question here is if you flip it around, how many orders of magnitude is a garden snail than that at a peregrine falcon. So I'm doing the snail compared to the falcon. So we're going to have to put this as powers of 10. We're going to have to round each of these to the nearest power of 10. So 90 would be close to 100, and 100 is 10 squared. So a peregrine falcon would be 10 squared. Now a snail is 0.01. That means that is 1 over 100th, which would be written as 10 to the negative second power. Or you could put this as 1 over 10 squared, which if you put it as a power of 10, base 10, it would be the negative second power. So 10 to the negative second power. If we do the division, when you divide like bases, you subtract the exponents. So negative 2 minus 2 would give us 10 to the negative fourth. And 10 to the negative fourth, we would say how many orders. The orders would be your exponents. So we would say the orders of magnitude would be negative 4 times. Next, the approximate masses of an amoeba and a blue whale are shown. Approximately how many orders of magnitude as a blue whale is an amoeba? So think of it this way. An amoeba is how many orders of magnitude as great as a blue whale. So we're going to do amoeba compared to a whale. And since the mass of an amoeba is about 0.00001 grams, so that would be the same as saying 10 to the 1, 2, 3, 4, 5th power, so negative 5, divided by the whale would be 1, 2, 3, 4, 5, 6, 7, 8, 10 to the 8th power. And when you divide like bases, you subtract the exponents. This will give us 10 to the negative 13. So the orders of magnitude would be a negative 13 orders. Next one, the radius of Earth is about 10 million meters. The radius of a virus is about 0.0000001 meters. Approximately how many orders of magnitude as long as the radius of a virus is the radius of the Earth. So we're comparing the Earth to the virus, and the Earth has a radius of 10 times 10 to the 1, 2, 3, 4, 5, 6, 7. So 10 to the 7th. A virus has an order, power of 10 raised to the 1, 2, 3, 4, 5, 6, 7. 10 to the negative 7th. So when we divide like bases, you subtract the exponents, which will give us 10 to the 14th, which would give us 14 orders. And our final question, which we just did here. So if we were to write our answer as 10 to the 14th, that means we have 1 with 14 zeros. So 3, 6, 9, 12, 13, 14. So it would be part D would be how much greater the radius of Earth is than the radius of the virus. And how many orders we said was 14. So that is our lesson on negative